Hello, friends. Good evening. I'm Harapriya. So, as we discussed in the previous class, I discussed about the introduction of the algorithm and what is the impact of algorithm in the complexity analysis and whenever we are analyzing the space complexity as well. So, in this class, we are going to be understand like how this input size and input type consideration is having the impact in the context of large input size, okay, and over the best case, worst case, and average case analysis. So let's start. So, so first of all, I will give you one example. So here, whenever we are talking about the input size and input type consideration, we have to be always go with the input size and input type. So in the previous class, already I mentioned, whenever we are going with the input size, number of inputs matters a lot, and algorithm need to be short. Because if it is not sorted, then we can't work over the particular inputs. Then we have to sort it. Okay. So for that reason, we have to work over the input type that is which is already sorted so that we can work over the reverse sorted and we can analyze the best case, worst case, and average case. So here you can see the example of sorting. So first of all, you can take sorting of mobile phone database in telecom operator. This is also one of the example. Or else you can take the example approximate subscriber base of Airtel 1 by 2 billion. Or you can take the example of naive string algorithm. This is one of the best example of inserts and sort and where the order is n square. Next, better sorting algorithm will be work over the quick sort algorithm that we'll see in the next whenever I will move with the next part of the class. We can identify this how the quick sort of order n log n is amplifying and how this n log n is going to be computed over the complexity analysis. So as part of analysis, one needs to decide which algorithm, how do we quantitatively compare the algorithm. That means whenever we are studying about a algorithm subject, that time the analysis is very important. That means we have to compare the algorithms. Okay. So now we will be moving the typical processor performs like how the typical processor is performing based on the 10 to the power 8 operations and the per second how it is working. Okay. So I hope you clear with this. So next we'll move with the part of like what is the example and if we are going with example then what is the order of that. So here whenever we are working with the sorting then the example will come under naive algorithm where the order is n square. So here you can take the value like 1 by 2, 10 to the power 9. If we are going with the order n square, then value will be 1 by 2 of 1 by 2 and with respect to 10 to the power 18 operations. So here what will be the instructions? Instructions will be per second 10 to the power 9. So this is very easy. You can understand it. Okay, 10 to the power 9 instructions means again we have to take a for the this 1 by 4. That should be 0.25 of a 10 to the power 10. Okay. 10 to the power 10 seconds. So it will be moved with the 75 years approx. Then this is the example of naive algorithm where the order is n square. Suppose I will tell smart algorithm means it will be work over the computation time n of n log n. So n log n means we have to compute how? We have to take the value for n 1 by 2 10 to the power 9. So if I am computing over n log n, then it will become of what? 4.3, then 10 to the power 9, then 43 seconds. Okay. So I hope this is clear. So whenever you are going to be work with the algorithms or we are going to be work with the examples, what you have to take? You have to always remember the order. So you have to remember the order of naive algorithm is n square. Whenever you are going with the smart algorithm, the order is n log n. So based on your n value, you have to compute the order. So here we are going to be analyze order of magnitude. Okay. Based on what we are going to be analysis. So analysis of order of magnitude. So when analyzing algorithm, we focus mainly on the order of magnitude. So this is very important because we are seeing, sorry, in analyzing algorithm, basically what we have to focus, we have to focus of order of magnitude. Okay, then the constants can be ignored. So if is there any constant will be there, that we just need to be ignored. As n goes larger, order becomes more significant. If it will be moves with the larger order, automatically it will be becomes more significant. So now we'll see with the example. So already you know the order, order of magnitude is n square. So here we have to compute of 10,000 n. So although 10k looks larger, so here you can see 10k means 10,000. It looks larger, but whenever we are computing, you can see. So it will be work for n 100, n square is 10,000. So if we are going with the n log n, then 10,000 n, then it will be computed over the values. Then for n, like this, you have to continue up to the all the values, and we have to find for the order of magnitude. Once you checked with the magnitude, then you have to move with the n square is 10 times larger. So after computation, you can easily identify what is the how much time is larger. Okay, that order of magnitude. So I will tell you whenever we'll move with the next slides there how this order of magnitude will have the impact over the particular algorithm. Okay, so here limit as n grows very large, we are interested only in order of magnitude. So here basically we are focusing on what? Order of magnitude. So that we can analysis what is the time complexity, what is the space complexity of the particular algorithm. That means what? We can do the comparative study of the algorithm. So is t of n proportional to logarithmic L log n? So that we have to check if the value is t of n is proportional to logarithmic log n. Polynomial means it will be moved with n square and n cube. Exponential means it will be moved with the 2 to the power n. So we'll move with the next slide. So this is the worst case complexity. So worst case complexity means we are here based on the previously we studied what? Order of magnitude. Order of based on the order of magnitude, here we are analyzing cases. So first case we are analyzing the worst case complexity. So the running time also depends on the type of input. Always remember whenever we are analyzing the worst case complexity, that time running time always depends on the type of input. What kind of input you are working, that is plays a very important role. For example, let's consider searching in an unsorted array. Suppose you are considering for the unsorted array for an element. Algorithm would involve looping through the array till element is found end of array. That means what? Suppose we are having an unsorted array. So till the element is not found, we have to work with the loop. That means what? It will be work like that is the worst case complexity analysis because unsorted. So we don't know where exactly the element is there. So we have to search entirely the array, unsorted array to find the element. For that only, this is going with the worst case complexity. And end of the array means entirely we have to search one by one the element. Worst case would need n iterations because we don't know where exactly the number like element is there. So that it will need, it requires n iterations. Okay. So item is at end of the array. If it is end of the array, item is not present in the array. So the two condition will be there. Is at end of the array, is if end of the array item is find or element is find, item is not present in the array. That means either it will be there in the end of the array or else it will not be present in the particular array. So this is upper bound for overall running time. That is what it is called, upper bound of the overall running time. So one has to observe the algorithm to identify the worst case. So how we will be analyze the worst case? So we need to be carefully observe the algorithm to understand what is the worst case of the particular algorithm. Because worst case means we have to go with the end. Like one by one, we have to search the element where it is present in the end of the array as well. So that we have to observe the entire algorithm to identify the particular worst case of the algorithm. Okay, so next we'll move with the step count method. Okay, whenever we are analyzing the time complexity or order, like you can tell order of magnitude, that time For that, we are using this step count method. So what is this? First of all, you will get some basic idea. So some basic assumptions are there is no count for and. So here for this, there is no count. So each basic statement like assignment and return have a count of one. But if we are going with the basic statement like assignment and return, it will have the count of one. So these things you have to remember. So for which statement there is no count, for which one we are having the count of one. So from that we can analyze and we can implement the algorithm easily and identify the time complexity. So if a basic statement is iterated, then multiply by the number of times the loop is run. So first of all, what if the basic statement is iterated? Iterated means it move with the loop. Then we have to multiply by the number of times the loop is run. How many times it will be run? From that we have to multiply. Then the loop statement is iterated n times. It has a count of n plus 1. Okay. So why it will be goes with the if the statement is iterated n times, then it has to be count of n plus 1. Why n plus 1? Because here the loops runs n times for the true case and a check is performed for the loop exit. Okay. So for that reason only we are checking with the it has a count of n plus 1. The false condition, hence the additional 1 in the count. Okay. For the false condition, if the condition is false, then additional 1 is count. That is what n plus 1. Okay. So I hope you clear. So here due to the loop runs n times for the true case. Okay. For the true case, it will be runs up to n times. And a check is performed. And additionally, we have to check whether the loop is exist or not. For that n plus 1. Next one is you can see how the step count method is working. So first of all, sum of elements is given in the array. Algorithm sum of a and a comma n variable is taken. Sum of 0. If sum is 0 for I equal to 1 to n do then sum plus a of I then return sum. That means if it is mentioned with the count 0 1 n plus 1 n 1 0. So step count will be what? 2n plus 3 because 1 1 we added. If it will be goes with the 0 then 1 n plus 1 again n 1 and 0. So finally the total sum of elements in the array and it will be total will be what 2n plus 3. So this is the linear search. We can do directly array n key variable taken then initialization with 0 for I equal to 0. We have to check the condition I is less than n. Then the loop will be work y plus plus. If array of I is equal to double equal to key, then printf found. Then only statement will be found. Okay. Then you can see here I equal to 0 is an initialization statement and it takes a big of 1 time. So this will be go with the big of 1 time. If it will be moves again with the I less than n I plus plus loop, it takes big of n plus 1 time. Okay. Based on the statement, it will be move with the time complexity. So if array of I equal to key is conditional statement to takes a big of 1 time. If conditional statement, it will move with big of 1 time. Then printf found is a function and that takes big of divided by big of 0 big of 1 times. So therefore total number of time it is executed n plus 4 times. So this is very important while analyzing the time complexity. So as we ignore lower exponents in time complexity, total time became big of n. Lower exponent here we are ignoring. That is what the time complexity is big of n. So this is the algorithm matrix search algorithm, number approach, length. Then based on that loop will be work, then element found. So we have to check the element is whether element is found or not. Okay. So like the same way, these things you have to check and you have to find out for the time complexity big of n square. Here the space complexity is big of n square based on the algorithm. So this is the asymptotic analysis. So here asymptotic analysis means what? We evaluate the performance of an algorithm in terms of input size. So based on the input size, we evaluate the performance of the algorithm. So and not the actual running time. Here we are not identifying the actual running time. So what we are calculating? We calculate how does the time taken by algorithm increases with input size. Based on the input size, how the time complexity is increased or space complexity is increased. So main idea of asymptotic analysis is to have a measure of efficiency of the algorithm. Basically, asymptotic analysis means we are we are evaluating the efficiency of the particular algorithm or measuring the efficiency of the algorithm. So there is 3 asymptotic notations are mostly used. So what are that? Big O notation, omega notation, and a theta notation. So big O notation is, the big O notation defines as an upper bound of an algorithm. This is very important. Whenever we are going with the NET exam and all, they normally ask like big O notation is defines what? Upper bound of an algorithm. So the notation is f of n big O of gn. Okay, so if there is exist positive constant c and n0 such that f function n will be go with combination of c of into g of n, so that for all n greater than equal to n0. So you can check with the condition and how the function of big O of g of n is working with respect to the function n. Okay. Next is omega notation. Omega notation provides an asymptotic lower bound f of n big O, omega of gn if there exists positive constant c and n0. So this that will be big O notation will be work with the upper bound. This will be work with the lower bound, that is omega notation. If there is exist positive constant, then it will be moves with the such that f of n c greater than is equals to c computation of gn for all n greater than equal to n0. And we have to check with the notation f of n omega g of n. Okay, so this is theta notation. Theta notation will be work over the theta notation bounds the functions from above and below. So it will be checked both above and below. So it defines exact asymptotic behavior. So this notation is very important so that it will be goes with the above and below so that it can define exact asymptotic behavior of the particular function. So it will be work with the f of n theta of g of n. So if there is exist positive constant c1, c2 and n0 such that c1 combination g of n then less than equal to f of n less than equal to C2, then computation g of n for n greater than equal to n0. So here you can see this graph. Easily you can understand how it is going with the above and the below. Sorry. So the function will be f of n theta g of n. So this is the rate of growth like time complexity, name, example. One constant, then adding an element to the front of a linked list. Okay. So if log n means it will be move with the logarithmic. So here we are finding an element is a sorted array or not. So time complexity of n means name is linear. Then finding an element in unsorted array. So we are finding the element in a unsorted array. N log n means linear logarithmic. Then this is moving with the sorting n times n items by divide and conquer. Okay. N square means quadratic. Then shortest path between two nodes in a graph. We are finding the shortest path between the two nodes in the particular graph. Yes, NQ means cubic matrix multiplication. Okay, to the power n means exponential, the tower of Hanvi problem. This is very important. Mostly in GATE exam and NET exam, this kind of time complexity and what is the name and how the example is work, these things are asked. Okay, so this is very important to focus. So this is all about the introduction to algorithms and how the notations are working for the algorithm, and we studied something about like how the time complexity and the space complexity plays the important role, and what are the like complexity analysis, how worked, worst case means how it will work, best case means how it will be work. So these things we discussed. So this is the summarization of the class. So next class I will be tell with the like how proof of correctness will be work over the particular algorithm. So with this we can wind up this session. If any doubt you can put in the comment section. I will definitely try to answer all the things. So as these things are theoretical concepts, so you understand it properly, we'll move it slowly with the problem. Thank you.